Yeah, nice chair for me actually figuring out some AV tech. Cool. I'm Amy. I work for Meta in the UK, but this is not a talk that's sponsored by Meta. This is all of my own volition. And I'm going to talk about code-gen-driven development. Code-gen as in, as part of your build process, then some code is generated, code-gen. And I wanted to give a talk on how we do this with Xcode, but I realized I can't really tell you how to do some code gen without telling you why we might want to. So I've tried to give a whole bunch of background context about why I'm doing this, and it will all hopefully make sense. So let's talk about business logic. According to one of Apple's documentation, business logic refers to app-specific ways in which data is manipulated. Data modeling includes your business logic in addition to the data itself. So business logic, sorry, just a bit nervous up here. Yeah, business logic is an important part of your app, and you have probably been told time and time again to encapsulate it nicely, to keep it separate. And according to this, if we were thinking in terms of Apple's sort of classic model view controller way of building an app, I say classic because that's what they promoted before they invented SwiftUI, then you can see that business logic will be part of your model layer. So there was an article doing the rounds recently that I read titled, "What if your feature was a command line tool?" If you Google that, it's on Medium, you can read it. And this article, it says, on paper, it might sound obvious to decouple business logic from views. However, during regular day-to-day work, it can become blurry again where to put specific code. Regularly check in with yourself and ask, what if this feature should also work as a command line tool? And so this is suggesting that our business logic might want to sort of stand alone. Our business logic is the manipulations we apply, that our app applies to the data, our sort of domain-specific manipulations. They're essentially what the app does. And it's a good idea to encapsulate them. Hopefully this is not a contentious statement. And so how do we encapsulate them? I mean, there's loads of different answers to this question, and I'm just going to present one way that I've been using in a side project. I'm not saying this is the best way or what you should do or anything like that. This is what I've done. It might prompt you to have some interesting ideas about things for your own apps. So what if we wrote our business logic in SQL? I'm not going to go too far into why SQL, other than to say, it's a language that can do data querying and manipulation and is kind of designed for that. And if we did put our business logic in SQL, it would kind of automatically be encapsulated, because SQL couldn't go and accidentally refer to some views in our app or something like that. And if we had already decided that we're going to write all the business logic in SQL, then whenever you write some, it's obvious where to put it. And if you are on iOS, then this is you'd use SQLite if you wanted to use some SQL. That's a bundled local SQL implementation that exists on your device. But if you were going to write your business logic using SQLite and you were going to use SQLite's API directly, you'd still be scattering stuff all throughout your code base, because the SQLite API, it's a C API. It does bridge to Swift, but it's a bit frustrating to use. You have to throw pointers around and that kind of thing. There are libraries like GRDB that could make it easier, but you still got to do a bunch of architecting to make sure to keep the relevant layers of your app separate. And I knew about this other product called CGSQL. This is actually a open source library by Meta, and I have used this at Meta, but all the stuff I'm talking about now is about a side project that I'm doing that's not related to my work. So CGSQL, what does it do? It's essentially compiled SQL. It sits on top of SQLite, and it adds a bunch of features to SQLite. Things like type safety, stored procedures, that kind of thing. And it all compiles down to some C functions. And I'm going to go into that as we go along. So this is what I'm going to be talking about. Now, CGSQL exists as a Meta open source library, but Meta have not been updating it for a little bit. The original author of it, who has since left Meta, he's actually got his own fork called CGSQL Author, and that one is updated and is under active development. So if you're going to play with this, that's the one you'd want to have a look at. So what did I say CGSQL does? I said it adds some things to SQLite, so it's still using SQLite, but it's improving upon it. We've got stored procedures, we've got compile time, type safety and checking, proper nullability handling, all that kind of thing, extra language features. So it makes it more like a sort of more comprehensive language. And then CGSQL has a compiler called the CQL compiler, which will compile your SQL files and turn them into C code. C code with like a function to call and run each query or mutation. And that's great. So this CQL compiler, that's already doing some code gen for us, because it's spitting out C code. But it's still spitting out C code. It's still a frustrating API to use when bridged to Swift. So we're going to go do some stuff on top of it. So to put all this stuff in context, we're going to talk about an app that I'm doing as a side project. This is Deluge. It's my task management app. And I've been mainly using this as like a technology playground for me to try and find good ways to do app development. Therefore, it's coming along quite slowly. I'm sure you've all got similar projects. And so first of all, I am going to give you a quick live coding demo of how we can use CGSQL plus some code gen stuff to make it really quick and easy to build something. And I really hope this works. So you guys can see the Xcode. I can see the Xcode on the screen down there. And I just need to find the simulator, which is on my screen here. So yeah, this is Deluge. And I've just made a new screen. This is just a Hello World screen. This is where we're going to put some stuff. So at the moment, this screen is literally, it's a SwiftUI view that says Hello World. And you can see there's only one interesting thing we've got in here, which is this environment variable. This thing called mailbox, this is like the entry point to a bunch of the stuff I code gen. I will explain more about that later, don't worry. So first of all, so we're going to add a whole new feature. We're going to store some new kind of data. We're going to be able to add some data and see it. So first of all, if I go into my database schema, and again, don't worry too much about what's already in this file. Worry about what I'm adding here. So I have now, using pretty bog standard SQL, I'm creating a new table, Pragma demo items. And it's got this field called timestamp and this field called message. So I've put that into my schema and saved it. And now I'm going to go into this CQL file, which I've put just alongside my SwiftUI view. And at the moment, it's empty. So inside this file, I'm going to put a couple of stored procedures that will encapsulate our business logic. Now, these are not very interesting stored procedures in the grand scheme of things, but got to keep things simple. So what we've got a new demo item, and we've got a demo items procedure. Demo items, come on, that's the simplest SQL statement you can ever encounter. Select star from Pragma demo items. That'll just fetch everything that's in that table. I've not even put an ordering in there. And this new demo item one, we are inserting a new item. So insert or replace into Pragma demo items, and then we're setting these two fields, timestamp and message. For timestamp, this is a built-in SQLite function that just returns the current time as an integer. And for message, we're just passing in hello world. So pretty simple. Like one of these is a query that will return some rows. One of these is a mutation. So again, I save that. So now, let's go back into our SwiftUI view. And this time, I'm going to just put a couple of things. First of all, I'm going to put this state variable called rows. And this will store the things we fetched from our database. I'm glossing over some things like types at the moment. And then inside the body for our SwiftUI view, I will paste this code. And again, this is pretty simple SwiftUI for the most part. Inside a list, we're going to loop through each of the rows. We're going to use timestamp as an ID, because if you recall, that was what we used as the primary key in our SQL statements. And then we're just going to display the message and the timestamp. And if you notice that for the message, because that was optional, I've had to do question mark, empty string, because it was an optional type in the SQL. I didn't put not null in the SQL. Whereas the timestamp, because that was a primary key in the SQL, that's not optional. So I didn't have to do anything like that. I'm going to save this. Yeah, so the one other interesting thing down here, this is part of my Codegen, subscribe demo items. So that's subscribe and then the name of our query, and we tell it where to put the things. And then we've also got this button where we use the mailbox to call the new demo item, stored procedure. And pray to the demo gods, everyone. I'm going to click build. And this is all live. I've tested this 3 times, so it should work. Build succeeded, good start. And we now go into our Pragma demo screen. And the list is empty, but the add item button is there. And I press add item, and we've got an item. It's got, got the message, the hello world, and it's got this timestamp. Press it again. The timestamp's the same, because I'm not going to sit here talking about this screen for a whole minute just to let that increase. These things, they're stored in the local database. If I were to quit the app and relaunch it, they'd still be there, all persisted. And they're all coming into Swift as nicely type-safe things in this demo items row type. Yeah, so that's my demo of what this Codegen can give us. Thank you. So I'm going to talk a lot about what I just did and how we got to this point. But I just wanted to make it, I wanted to use that demo to make it clear how smooth this can make development once you're used to writing in that way. I wrote those SQL queries and that create table database schema, and then I just had access to them in the Swift code in Swifty type-safe ways. So this is some CQL code. I say CQL code as opposed to SQL code because this is the variant of the language that CGSQL has added things to. And there's a few things that it's added. One of them, we can run the C preprocessor. So I'm using that to include this file here, and that's just substituted in like, well, you all know how the C preprocessor works. We've got stored procedures. SQLite doesn't natively have those. CGSQL adds them. We've got parameters with custom types. You might notice there's a type there, UUID. That's not native SQLite, and so you can add types of your own. And it supports type checking, casting, that kind of thing. You can call out to your own C functions, or Swift functions if you use that CDeclar attributes, like we saw at a talk earlier today. And it supports interfaces, which are pretty much protocols for the rows it returns. There's a whole bunch more of this. So anyway, CGSQL adds a load of stuff to the language, which makes it better and more suited to writing business logic. And it also handles compiling this CQL code into some C code. And so at the top there, we've got a very simple stored procedure in CQL. Run the CQL compiler, and we get a whole bunch of C code which looks pretty inscrutable. And it's not that great. There's a few problems here. One of the problems is you've got to remember to actually run the CQL compiler to actually compile these things and then compile those C files into your app. And then the other problem is sort of twofold. The C API, it's very much a C API. It works with these opaque results sets. We're accessing them via indices. And also, it doesn't bridge to Swift very nicely. We're still doing things like using in-out pointers, and there's a number of reasons why this doesn't lead us to a very nice Swifty API. Anyway, we're going to solve those problems. And we're going to start with automating running the CQL compiler. Because, low-hanging fruit, let's make sure that when we press build in Xcode, it will do that. You saw in my demo that it did. So here we are in Xcode in the settings for our target. So you click on your projects in the sidebar, then you click on the relevant target. And we are in the Build Rules tab. And we're going to teach it how to understand a .cql file. So I've just added a new build rule, which runs a custom script. And this is a bog standard bash or whatever script. And you can use within that script some of these tokens like input file directory and name and derived sources directory. So what we're doing in this script, the bulk part of this script is essentially the command that you would type to invoke CQL. I'm not going to go through what that means. It's in the documentation. But I've put it in this script phase within Xcode, inside this build rule. And so when Xcode encounters a CQL file that it wants to build, then it'll call this script. The input file directory and input file name will be populated with the file it's trying to compile. And then this derived sources directory, that's where we should put stuff that we want Xcode to then treat as another source file. So the CQL compiler is outputting C code. If we shove that C code into derived sources directory, Xcode, when it's building, it'll treat that code as something else it should compile. It'll discover the outputted C code and compile it into your app. Automatically, magic. And one thing you have to make sure of is we're now in the build phases tab of Xcode. Compile sources, that's a default, that's already in there as a build phase. And the CQL files are in there. Now, it should, in theory, be possible to get Xcode to automatically put brand new CQL files in compile sources. I haven't figured that out, so I have to go and manually drag them in. But once they're in there, Xcode handles it all. So CQL files are now a thing that can be compiled according to Xcode. So we've, just as a side note, regarding running CGSQL inside your app, it's got a little runtime component, so there's a few files that you've got to have included in your app as well to make it all work. Cool. So you might think, I mentioned this derived sources directory, which is where we're putting the output of this compiler. It might be useful to actually be able to go and see what's in there. If you're debugging this stuff, you might want to see what your script is spitting out. And the way to do that is you go to Show Build Folder in Finder, and then within the build folder, then you can just navigate through the intermediates into your build folder again, into debug, again into your app's names build folder, and there's derived sources. And you can see I've got a whole load of stuff in there because I'm codegenning and compiling and making a load of things in this app. So that's got essentially everything you've shoved in there. And all the things you shove in there as part of the build process get compiled into your app. So we've solved the first problem, manually compiling the CQL. We don't have to manually do it anymore. It happens automatically. So let's solve this second problem where the API isn't Swifty. And if you recall, it had two parts. It doesn't bridge nicely from C. And working with these opaque result sets is annoying. So how are we going to solve that? Codegen. And I like that animation. I'm going to use it again later. So let's analyze what we actually want to happen. So we want an object that we pass around as like a dependency injection. I've called it mailbox. The only reason I call it mailbox is because CGSQL was first used in Facebook Messenger, and Messenger has a mailbox. That makes sense. And I adopted the term and haven't changed what I call it. But this is essentially a thing which encapsulates your database access. This is my object. I've made this. So on our mailbox, we want to be able to call things like query, whatever. So any of our SQL queries, we want to be able to do like query rooms list or whatever. and we want it to return a nice type that's maybe a Swift struct, that's a nice immutable struct that's got all the fields as Swift types. It can be equatable and hashable. You might notice that I've got this protocol here, room. Well, if each query is returning a different type for its rows, you're going to want to be able to do things like reusable views. And so you're not going to want to have to make your view adapt to every single possible query your app can have, so let's use a protocol. That's just a Swift protocol, which in this case, we're fetching rooms, so it's a protocol called room. So you can do all that kind of thing. And then we're going to want to be able to call CQL stored procedures that aren't queries. And what do I mean by aren't queries? Well, queries like return some rows, but you've also got things that might do a mutation and not return anything. So in this case, we've got something which takes a bunch of arguments, because you pass in arguments. And all of this will be defined in our CQL stored procedures. We just want to map them to Swift APIs. But in this case, it doesn't return anything because it's not a query. And you might want to be able to subscribe to updates. And that's what you saw in my demo, was whenever the database table was updated, then that screen got an automatic callback. It got new data passed into it. So this is the API we want to make. So how would we go about making that manually? Like if I was making this query room list function, let's assume that we've got our room list CQL stored procedure. And if I wanted to make a Swift function that will go and do that, we'll go and call it, using the C API that CGSQL provides, I'd have to do something like this. I'd have to check that the database is valid. We're in an extension on Mailbox, so database will be self.db. We have to check that's valid. We'd call this room list fetch results. That's the thing that CGSQL's compiler will output. And then we want to iterate through the returned results and construct one of our Swift structs for each row. And then we want to return that. So it's all pretty simple. This is how we would wrap that C API into something which offers a Swifty API. But we don't want to do it ourselves. It's time for, thank you. So how am I going to do some code gen? I'm going to do some code gen using a script. But I'm going to write the script in Swift because when all you have is a hammer, then everything is written in Swift. So this is essentially writing a Swift command line tool. I think we've got to talk about that later in the conference, so yeah. You could write this in Python or something else if you're masochistic. Now, I've put the CodeGen script in my Xcode project. That's just to make it convenient for me to get at it. You want to make sure it's not in your target. We're not compiling this into the app. This is a separate script. So how do we, first of all, if we're not compiling it into a target, how do we compile this script? So now I'm in the Xcode build phases tab for my target. And I've got this build phase compile CodeGen script. So again, I added a new build phase to run a script. That's what I titled it. And what does it do? It uses xcrun to compile my scripts into a Swift command line tool. And again, this is exactly the same as if you were compiling it yourself using the command line, using xcrun. So as part of my build process, I'm compiling my CodeGen script into something that I can actually run. Next, let's talk about what's in the CodeGen script. Now, my actual CodeGen script for this project it does quite a lot of stuff. I'm not going to show you the actual scripts. I'm going to show you key parts of it. And the main thing I'm trying to do here is I'm trying to inspire you. I'm trying to show you what's possible in a way that you can then spend time looking into exactly how to do each thing that you particularly want to do. So where do we start with this CodeGen script? Well, we still have access to these environment variables that Xcode is setting. If you recall when we were talking about automating the running the CQL compiler, we had these input file base and things like that to tell it which file was being compiled at the time. So we still have access to these. They're going to get passed in when our Codegen script is run. So we've still got access to input file base for the file we're looking at. We've still got access to derived sources directory, which is where we're putting stuff we're outputting. And if you recall, we put the C files that the CQL compiler outputted into derived sources. Well, we're now going to output some Swift code, and we're going to put it again into derived sources so that it gets compiled into our app. So derived sources is pretty magic. And so the main concept of this script is we do whatever it takes to generate some Swift code. And then the code that we've generated, we will write it to a new file that's named the same as the input file we're looking at with a .swift, and we'll write it out into derived sources. And going back to our build rules tab, and the build rule we already looked at, the CQL build rule, well, actually, at the very bottom of that, after running the CQL compiler, we now run our Codegen. And so this happens in the build phase after the Codegen script has been compiled. So that's how we compile and run our Codegen script. But I'm sure the thing you're all wondering, the elephant in the room, is how do we know what we're going to Codegen? And you might be thinking, oh goodness, is it like Swift macros? Are we going to have to import the C equivalent of Swift syntax and go and parse abstract syntax trees? No, we're not. Not in the slightest. Because the CQL compiler, as well as spitting out C code, it spits out a JSON file. And this JSON file is really useful. Here's just a little bit of it. This JSON file describes everything that the CQL compiler compiled. So here's the bit of it for one of our queries. It's got the query name up the top, and it's got this thing called projection, which has the name and type and various attributes of every field in the rows that it's returning. So we know what to do with a JSON file. So back in our Codegen.swift, then we can read in a JSON file, and we can do some JSON parsing. So this JSON file, that will appear in the derived sources directory, because that's where the CQL compiler has been putting stuff. We can read it in from there. And we can use, we're writing in Swift, we can use Swift's JSON parsing to parse it. Now, I'm not going to show you the way I've modeled all the things that can go in that JSON file. But it's just a bunch of Swift structs that corresponds to the JSON schema that CQL outputs. I trust all of you could do that if you tried. But yes, so within our Codegen script, we do this JSON parsing, and now we have access to a structured representation of exactly what the CQL compiler has output. And then, for example, for the part of the Codegen where we're going to be dealing with queries, so document is my parsed JSON, and it's got a whole bunch of properties. One of these properties, it's called sprox, or sprox. It stands for stored procedures. And if you recall, I mentioned that stored procedures can be either a query or a mutation, for example. So we're taking our sprox, and we're filtering them to ones that do have a result. So queries have a result, they output something. If they didn't have a result, then they're either a mutation or something pretty useless. So again, this is just me filtering the stuff that we got out of that JSON file. And then I've got another function that I'm going to call, and I'll show you this on the next slide, which will write some Swift code. And that will output the Swift code just as a string. So all we're dealing with here is strings. We're making a string of all our Swift code, which will eventually get written to disk. So let's look at this generate for query function within our Codegen. And don't be scared that I'm about to present a full slide of code, because I'll tell you why I'm showing you this. I'm showing you this to show you that most of this is a string. It's a string where we substitute things in the relevant place. And so, for example, in this string that we're building, and we're just doing it using bog standard Swift string concatenation, you can see we've got, can I have a mouse pointer on there? No, I can't, it won't let me. Oh well. We're building this function, query something. And the something is query.name. That's come out of the JSON. So we're building a Swift function that starts with the word query and then has the name of whatever the query we're codegenning is. I've got a bunch of helper functions that I call out to, like Swift args for query func signature. That will convert the arguments types from the CQL types to the Swift types. But none of those are scary either. They're not magic. They're just iterating through each item in the JSON file and working out the Swift equivalent. And the code in there, if you recall, we said we were going to start by checking if the database was valid. Well, that's what I do. You can see this guard statement in there. And then we said we were going to call the relevant C function. And this codegen is just built up by filling in the blanks like that. And I developed it, just by building this stuff. And then when you run your Xcode build, if either the Codegen script doesn't compile or the output of the Codegen script doesn't compile, your build will tell you. And so I'd be going and looking at the files in derived sources, working out if they were generating the right things for me. And so let's look at just a tiny little bit of this. I've got a little bit of time. So this is generating the struct that represents the results type for the query that we're caring about at the moment. And what it's actually outputting once those blanks are filled in is that. So, struct query name row. In this case, it would output a thing struct room list row. And then we iterated through each argument in the projection and made a variable within that struct. And you can see the output there is Swift code. We're just building Swift code out of strings. So nothing particularly scary. And as I mentioned, this runs as part of your Xcode build process. You'll see this run shell script. And the good thing is you can actually, anything your Codegen script just prints, just using the print command, will appear just there. So what I'm actually doing here is I'm printing the entire parsed JSON file so that it's there in my build log if I need to go and check why something isn't working. But you can print anything, so that's a good way to debug your Codegen. And these things that we're Codegenning, because we put them in derived sources and they get compiled into our app, they show up in autocomplete, and you can just use them. They're just Swift functions. So let's review the parts of the system that I've just talked about. So we've got this run script build phase, which compiles the Codegen script. And that's just because I wrote it in Swift instead of something interpreted. We've got this build rule for the .cql files. And that first runs the CQL compiler, and then it runs the Codegen script. And then inside the Codegen script, which is written in Swift, we parse the JSON output of CQL, and then we build and emit some Swift files into derived sources. The Swift files extend this mailbox object with a method to run each query or call each mutation. And we also build a struct which is for each row for the output of each query. And then the outputs of all of this stuff are compiled into the app. So how does this solve the actual problem we're trying to solve of encapsulating your business logic? Because we should probably take a step back. So the business logic is written in SQL, specifically the CQL dialect or variant. And so we've got queries that return this immutable array of structs, and those structs go on to populate your views in Swift. And so we can use these protocols for reusable views, again, just like any sort of data model type stuff. Mutations, they're also written using SQL stored procedures. And actions taken in the UI should call a mutation. And then the view automatically refreshes. I've put right with question mark because I haven't actually talked through how the subscription stuff works. But it's just another layer of the same. It's just more code gen. One of the things that the CQL JSON file contains is which tables were affected by a mutation. And so for subscriptions, you just have things subscribe to the tables they care about. And then we store a closure for we store a closure in the mailbox for what to do when those tables are updated. And then as part of the code gen that we generate for these for running our queries, we make sure that we trigger the subscriptions. So again, it's just layers of code gen. You can generate all of this. It'll all happen at compile time. It'll all be nicely type safe. So within Deluge, within the app that I'm talking about, I've code genned a whole bunch more stuff, which, we've got the subscriptions, just mentioned those. I've code genned some stuff for mocking data, which we can use in like SwiftUI previews or testing. So instead of hitting the database, it'll return some mock data. You saw the view modifier in SwiftUI for the subscriptions. That was a nice one-liner. I've added undo and redo. And we've got things like bridging to Swift enums, including the union types where the enums can have associated values within the cases. I've got some support for Swift concurrency. All of this stuff was built with CodeGen. And more. And I've got one more thing. I don't know if anyone even gets that reference anymore. It's been, how many years since Steve passed away? So inside Xcode, you may have seen that my CQL files, they look quite nice. They're syntax highlighted, they've got some indentation. And you might say, how did I get them looking like that? And you can build these things to extend Xcode. So I've built an IDE plugin and an XClang spec. The XClang spec is the one that handles the syntax highlighting and indentation. And the IDE plugin handles knowing the concept of what a CQL file is. These things, they're not really documented, but you can find examples on the net. So you could make Xcode able to deal with essentially any file type. You can be bothered to go around and analyze exactly all the different tokens it can have. Yes, so that is it from me. And I actually finished before time, so there is time for questions.
Yep. Yeah, I think we can do one question before the coffee break. 2 hands, more hands. Anyone higher? It's a bit. Come on. Yeah. Let's pick the non-blue shirt guy. The white shirt guy.
Hi. Great work. I just kept thinking about why not implement everything in a Swift plugin? Because the logic can be implemented there, or were there any impediments? I was thinking as an Xcode command tool plugin, so you basically don't have to add Swift package support to it, but you can run from every Xcode project.
Yeah, great question. So a lot of this is because I used what I knew, and I've been doing things like this since before those things came along. Regarding Swift plugins, I mean, there's 2 things you could be talking about there. One of them is the plugins to like Swift Package Manager or something to be able to trigger things as part of the build phases. Yep. Is that the one you meant?
Yeah. That would be an Xcode build tool plugin, but I was thinking about a command tool plugin, so you don't have to integrate it on your build tool phases, because the logic, as far as I saw, does not have to be implemented in the build phases, but you can just run it through a command.
Yeah, I mean, definitely something to look into. The only reason I can say for why I haven't done it is because I did it this way.
Thanks.
Great answer. Best answer today, right? Let's do the one more question, and then we'll go to the coffee break.
Thank you very much. The same place. Thank you for your work. I was wondering, why do you use? Is it particular reason to use CQL instead of core data, for example?
Yeah, it's a different sort of way of thinking about the sort of model layer things. I can give you a much deeper answer over the coffee break, actually. Core data, it has very much the philosophy of mutable data models inside editing contexts. And, you know, I love that stuff. I was using enterprise objects before core data even existed. But it's a different way of modeling your data model. And especially these days with the push towards Swift concurrency and the push towards using immutable model objects as far as possible and encapsulating the sort of mutation actions in their own thing, it's a different philosophy. I'm not saying it's necessarily better, but it seems to me that it's where the wind is blowing.
Thank you.
Thank you for the questions, and thank you, Amy. There was like a whole lot of stuff that we got a small glimpse into. I hope you keep sharing because there's super many interesting things in there. We have the coffee break now, and we'll be back here for the last session of the day. I think I got it right this time. In 26 minutes sharp. Thank you.